All right, well, we're missing one person, but the three of us here, you want to introduce yourself?
Sure.
Good afternoon, everyone. I'm Robert Prather from the 777 Project. Started my project in 1998 and have been obsessed with it ever since. Kind of starting off like these gentlemen talked about, using a lot of homemade panels, then replica panels, and then eventually progressing to pretty much all OEM panels. So when you see the 777 rotating behind us, that's my project.
There he is.
I took my way out of being arrested, so I've got 5 minutes before I get locked up. I'm Bernie, by the way.
Oh, yeah. Go ahead and introduce yourself.
I'm Bernie.
Just Bernie.
That's right. I'm Fabian. I have a 737-800. If you missed the first part of it, it is mostly using real parts.
Yeah, and I'm Tony Wilco. I've got a 737 build that's not real, but it's all simulated parts, and it's almost complete now. I've been doing that for about 10 years. So the whole idea of this panel was just we'd get a bunch of us builders up here, and you guys out there who have questions. We went through the material really fast in the last presentation, so we didn't really have time to kind of go in detail on anything. And I apologize for that, or take any questions. But that's what this kind of informal opportunity is for us to kind of go back and forth and even talk between us about things that we've dealt with during our builds and how we've kind of overcome them. And then if you have questions about, hey, how did you do this or that, or what do you think about, we're happy to kind of have that conversation with you.
So I have a question for y'all. Anyone doing a fighter? They can hear me.
No, you need
I have a question for you guys. Is anyone here building a tactical aircraft, fighter-based airplane? So we're all carrier-based aircraft. 737 is the smallest we do.
Yeah.
Okay, cool.
So since Bernard doesn't want to mention too much, he's got a 747-400 simulator built with real stuff, and it's unbelievable. You'll probably see it pop up here behind us. These are just a slideshow of all of our different, in no particular order, they're just pulling up, but he's got that, and he's got a tactical aircraft that you'll see pop up in there too. We'll leave it a surprise. You'll be able to pick it out when it comes up. So he's got a lot of experience. We all do. We all have a lot of great experience. So are there any questions to start that you guys might have for us? Yes, sir. Here.
Yes, I'm very new to the home cockpit building experience, but I elected to start on a 727, so I just picked up a bunch of real panels because there aren't really any, sim panels made for something like that. Is it a bad idea, or do you see any major pitfalls to maybe working on the individual instruments and wiring those up individually, or working on the panels before really going and setting up a shell and building a platform? And because, like you guys have all said, it's a 10-year long project, so it might be like 10 years of having a giant box sitting there that you can't really use that much. So
I would say, in my opinion, like, it's all about enjoying it, right? Having fun doing it. If you enjoy building that panel, and that's part of the hobby, right? Seeing that panel come to life, you move it, and then it does something in the simulator. That's so you don't have to have it all ready. That's part of the process. So it's how you get started with learning too, right? Once you get that part, like put it all together inside a cockpit, is probably the easier part.
Yeah, I mean, like I talked about, there's no instruction manual, so there's no real order to doing things. It's whatever works for you, and whatever keeps you motivated. So if doing that is what keeps you going right now to a later stage, then by all means, if you can logically fit that into what you plan to do later, right? But I don't have a particular order of things, right? Go ahead.
Hey, Justin, I have a different approach to this, right? I think your approach is the intelligent way to go. The reason why your question is so intelligent is because you are learning to control and be master of your own environment, so you will not have a reliance upon third parties or third-party vendors. So your learning curve and the time that you spend into learning to do those panels is going to save you excessive amounts at the end because you're going to be able to plug it in. You're going to be able to do the documentation on your own pace, because if you don't document it as you go along in terms of the wire numbers, etc., that you devise, you're not going to be able to control your environment. So I personally feel that your approach is correct.
So I'll share something I would have done differently. It was probably 10 years before I had a flyable simulator, because I started with components that did not, they were not core to flying. If you start with, for instance, the instrument panel, and I think Fabian brought this up, an instrument panel, flight controls, rudder, yokes, rudders, yoke, and throttle, you'll have a simulator that you can at least fly along the way. That would be number one. Number two, I would urge you, try to keep your instruments intact. I can't tell you the regret that I have for getting some very difficult to find parts and gutting them and thinking that we'll never be able to connect them the way that they were in the real aircraft. And now I'm like, holy cow, why did I destroy this beautiful, priceless panel? So to the extent you can keep your instruments intact and just vary the voltage to them or whatever, you'll have a beautiful simulator. And if I can go back and do it again, I would probably do a simulator that's kind of the old steam gauges. There's just a beauty to that and seeing those needles come alive in the cockpit.
All right, what else we got? We can have a conversation between us because there's plenty of things we can talk about.
Sorry, I'm just a dumb pilot, but I like listening to all this stuff. Is there a particular reason? I know you mentioned 7.3 is kind of easier to find, but you did a 777. Is there a personal connection that you guys have with these airplanes, or is it just I picked it and I went with it?
Yeah, go ahead. Here.
So ironically, when I was starting, I had a choice between two airplanes, the Pilatus PC-12 and the Boeing 777. And the reason I went with the 777 is I thought it would be easy because at the time, this was like pre-737 MAX. The instrument panel on the 777 is almost entirely digital. So I'm thinking, man, slap some screens behind there and a landing gear, and I'm done. And 20 years later, I'm like, what was I thinking? I'm still not done yet. But also, I just 777 to me is just a sexy aircraft, right? Just the Boeing brown, it's just an inviting color, just beautiful panels. It's just everything about it. I love the flow. I love the big switches. I love the square Corey switches that all light up green versus more the flip switch. So for me, I just think it's a beautiful aircraft, but I literally thought it would be easier because everything is the big multifunction displays. Not quite.
My approach was different. I wanted the biggest, baddest thing you could possibly have, right? And don't get any bigger than the 7.4. But what drove that particular airframe was primarily the software, right? And the ability for me to be able to purchase the entire cockpit.
Yeah, I would say for me too. Like when I first started, I was doing a 767, which is one of my favorite airplanes. But I was using the level D 767, which they really stopped supporting. And then I was looking for aircrafts that had really good support. And I always loved the 737 too, because it's the right size aircraft for long or short, mostly short, medium size flights. So for casual flying, it's great. And then it had the support to be able to get the software right. It's very important. You can't just pick any aircraft. I mean, you can, but if you can't have the software for it, then you're not going to get very far. So being that there's a lot of software suites for the 737, that's what kind of encouraged me to move on with that.
Yeah, and we just by coincidence happened to build a 737. I mean, the Airbus A320 is also a really popular airplane, yeah. And there's a lot of support for it. So that's why you see so many of those in the community. The A3, I haven't built an A320, so I can't say whether it's easier or not. I imagine, just like you've mentioned,
definitely easier.
There's more fly-by-wire stuff in that, right? But it still has its challenges too. So I wouldn't necessarily say it's easier. What's that? Yeah, you've got the joystick on the side. It's a different environment. It's a more comfortable cockpit than the 737 is for sure. It's very tight in the 7.3. The 777, you got plenty of room. Same with the 7.4, right? But also with bigger cockpits comes more space requirements, right? So that's another thing you got to weigh is how much space do I have? Because the 7.3 only takes an 8x8 space really for just the shell itself, and you get a lot bigger. I don't know what's a 777 footprint.
10.5 feet wide at the base at the
Yeah,
back.
yeah. So you're getting a bit bigger now, you know. And then you got to take into account all the stuff around it, right? You're gonna have displays out the window, those take up space. So yeah. So my decision was just I thought it was a beautiful airplane. I love the 7.3, and like you said, it's very versatile. You can get in and out of a lot of places. It's just a good looking airplane. There's a lot of support for it, so there's a lot of reasons, and that's why you see so many of them out there and replicated so many times by so many different people. But that's good. I mean, that helps us because there's such a common bond that there's a lot of people that you can talk to about, hey, you're doing a 737. How did you do this, right? So it gives you that extra level of support. Yeah. But there's plenty of other great aircraft out there too. So.
That's what you meant by support, is other people.
Other people in the community, right? Well, not just that, but vendor support too. Because most of the vendors are selling, you can find 737 parts from almost across all the vendors, right? But, you know, if you're looking for, let's say, a 7.4, yeah, 777's not too bad supported, but there's a lot less supportive products out there for the 777, the 7.4, than there is for the 7.3. Because everybody's doing 7.3, so that's what they're making them for, right? Same with the A320. If you were to do a 757 or a 767, good luck finding parts. There's not many people that make them, right? So you're going to find yourself building your own parts a lot, right? So that's where you got to get savvy with 3D printing. Maybe you make your own acrylic panels, you know, laser etching, all that kind of stuff. But with that comes investment in tools. So you got to kind of weigh tools and skills, right? Because you got to learn how to do it. I mean, I didn't know how to do any AutoCAD stuff at first, but you know, I knew I needed to make some 3D parts, so I learned how to use a 3D printer. I found Autodesk Fusion 360, and I started building my own 3D models and then printing them out on a 3D printer. So things like, you know, the window handles or, you know, little knobs or things like that I couldn't find. And there's another thing that I said, you know, it takes sometimes a really long time to get parts from people. A lot of these companies are overseas. They're not here in the U.S. There's very few that are here in the U.S. that sell parts. I think you got Flight Deck Solutions, which is in Canada, which isn't really selling too much to the enthusiast market they used to. Outside of that, I don't know, who do we have else here in the U.S., right? Everybody's overseas.
Right.
So then you got to, you know, this is such a niche hobby that if you buy a part, they probably are not going to have it on standby. There's a good chance that they've got to make that part for you and ship it to you. It could take months, right, depending on their backlog. And then you got to pay shipping costs to get it from, you know, Europe to here, which is not exactly cheap anymore. So, you know, these are all things you got to factor in, and that's why getting savvy on building your own parts is a really good thing to do, because you can get those parts right away rather than have to wait. You know, things like learning how to make a printed circuit board, right? You know, that comes in handy. You could make your own backlit panels. I mean, you can do all of that, but there's a very big upfront cost in time and investment in the equipment and your knowledge to be able to do that. So, you know, those are things you have to weigh.
So we did have a question you were asking about what avionics do I use? Maybe I can touch on that. So in my 777, I went a slightly different route. I've used different packages. I started off in the early days with Project Magenta, and then I developed my own synoptic displays. And then when PMDG came out, I was very intrigued. I thought they did a great job with the 777 model. And so now what I did is I actually took the aircraft and undocked the screens and slide them over, and that's how I powered the avionics in my simulator. But then a lot of people ask, okay, well, then how do you do the electrical interfacing? So I've had to kind of create my own electrical interface, but the bottom line is for the avionics, I have found PMDG, it did a really good job, a very detailed job, especially for the 777. And that's what I use for my cockpit.
You bring up a good point, because with PMDG, so one of the advantages of using a dedicated avionics package like ProSim or Sim Avionics is they have the interface, the electronic or the software written to quickly configure buttons and indicators and stuff like that, right? And the interface, the drivers that connect to the hardware to talk to all those things, right? When you have something like a PMDG product, you don't have that interface, right? So you've kind of got to figure other ways to be able to do those same things. And I don't know, how did you overcome that, like FSU IPC and
That's right. So, my focus the last few years has been building electrical interfaces, and so that's what I've overcome it, is basically creating my own. But it's using FSU IPC, event IDs, and that's been the best way forward.
Yeah, and that takes time because you've got to learn the SDKs, you've got to learn FSU IP is a big add-on that allows you access to a lot of the button, the variables, right, within the simulator to do different things, right? So, and you probably would explain it better than I could, but FSU IPC is really important, at least, in MSFS and in Prepared, right? So, and that actually brings up a question in my mind, like, okay, so what simulators do we use, right? What is the core flight simulator software we use? I know you use Microsoft Flight Simulator. What are you using?
So I've got a bit of a hodgepodge. So my graphics are Microsoft Flight Simulator 2020, but the logic is actually run out of, I've got one computer that can run either FSX or Lockheed Martin Prepared, mainly because it's an older computer, so I get better frame rates from FSX, and it's not having to drive any graphics. But then I've got an application that runs in between called WideView, and WideView now supports something called mixed mode. So I can run all my logic and avionics on Lockheed Martin Prepared, and then have Microsoft Flight Simulator 2020 simply running the graphics. So then I can overcome maybe some, I understand FS 2020 still leaves some things to be desired in terms of integrating with home-built cockpits, but FSX and P3D do it great. So I run a combination of both in my sim.
Wow. Mine's just a beast. You just do not want to do this, right? So my avionics suite is PSX. My out the window view is Prepared 3D. So what's that? Oh, my communication devices are the aircraft computers. None of them want to talk to each other. They all conflict. It's hellaciously expensive, and it's also easier. The reason why it's easier is because the wiring is already pre-done for me, and all you have to do is get access to the wiring diagram manuals. You can get OEM manufacturing support. You just have to jump through the hoops. The issue with the real stuff is when it breaks, it's the same price as the airplane, right? It's hellaciously expensive to maintain. And the other thing is the cost, the not only the cost of entry, but also the cost of maintenance, right? It's hellaciously expensive to maintain, both in terms of costs and in terms of environment and time.
What are you guys doing for your visuals? Your out the windows views. I know Bernard's still trying to figure it out.
Ooh, right. So with the 7.4, I have single pilot eye point collimation display, and for the other one, I'm going to use augmented reality mixed with virtual reality because I want to keep my the external environment of my second project intact. Am I making sense?
Mine's real simple, 3 75-inch TVs multiplexed into one super wide image.
For me, I used to have a curved screen with 3 projectors, but I wanted to move on to 4K, and unfortunately, I was not able to find a 4K projector that was short throw that worked with the size, my room size. So I try now ultra short throw projectors. They're 4K and they're decently priced, but the only problem is they don't work with curved screens. So currently, I'm using 3 120-inch screens, flat screen projection screens, and they're just like 45 degrees front, 45 degrees, and the 3 projectors. And it works pretty well. I'm using Microsoft Flight Simulator, so it's still a little hard to align. not using fly least yet, but I love the 4K on that, so that's kind of like the benefit when I'm doing it like that.
I also have single eye point collimators that I got from a friend. They were in bad shape. I don't know if you all know about what a collimator is, but so like when you put your VR headsets on, any of you used VR headsets like Oculus and whatnot, right? So if you look at the lenses, those lenses are actually collimated, meaning that it causes the light rays through mirrors and physical trickery to cause the light rays to come at you straight, at your eyeballs straight. That gives you the sense of depth perception, right? So collimated display, if you've ever seen on the level D full motion flight simulators that they use at the airlines to train, they have that wraparound screen, right? It's like a mirror, right? And it's a Mylar film that they vacuum form against a parabolic mirror that wraps all the way around, right? That causes the light rays to collimate, which causes them to come at you parallel. And when you look out the window, you can, far away looks far away, close is close, right? So that's kind of the same thing I have. I have an older version of that. And they're just individual mirrors rather than a one wraparound mirror. But there's complexity in that too. What's that? Oh, there's a question. Go ahead. Yeah. What are good resources for projection or collimation?
Him.
Yeah.
And him.
Yeah. Collimation, I can tell you, I don't want to say don't do it, but it is very different than a projection setup. There's a company called Fly Elise that makes warping software, and they have a manual that tells you kind of how to make your projectors work in a curved environment. Because if you take a projector and you project it against a curved surface, it's going to cause the image to warp. You're going to get like a bow at the bottom, right? And so you need warping software to be able to straighten that image out, right? And then you need the warping software to also, if you have multiple projectors, to kind of combine that image so it looks seamless all the way across. And then if you have multiple projectors, you have potentially different brightnesses of projector, different color intensities, all that kind of stuff. So the software also helps kind of blend the different intensities so that everything looks seamless. And that is an art. That really is. There's people who specialize in doing that. I would suggest probably Fly Elise's website and look at their manual, because you can download that for free and see how they do that. For collimation, I haven't figured it out yet. I use the warping software because I have parabolic mirrors, so my images are bowed on my screens. And focusing those mirrors to a single eye point, because they're called single eye point because everything looks right in one place, right? A level D simulator with a wraparound collimators, wherever you sit in the cockpit, it looks right. But for mine, they're single eye point, so you have to be in that one place for everything to look right for those mirrors. And that's tricky, because if I lean over, everything gets out of alignment, right? If I lean forward, the image gets bigger, right? So it's only meant for that one point. And there's nobody out there really that's doing that. So you kind of have to learn on your own. So I use the Fly Elise software to fix the warping issues, but I still haven't gotten it down right. But if you have questions about how to do a collimation, if you have one, I'm happy to work with you to come up with a solution. I hope that answers the question.
I have a detailed question. If you're going to make your own panels, let's say you couldn't find something, whether it's on the knobs or it's on the flat panel itself, there's always printed writing. I'm interested in what you all have done, what kind of techniques you use for getting that right, crisp, clean, unsmudged.
Have you done panels? Okay.
So I've worked with quite a few companies that do that, and the process that I've seen them work with some success is starting with clear acrylic plastic. They apply a base coat. I think it's a black base coat. Then they apply a white coat over the black base coat, and then they apply the actual Boeing color on top of the white. Then use a laser to etch only through the brown, which exposes the white below. But part of the magic is on the back of the panel, they CNC mill out the panel to make holes in basically gaps in the panel where you can put LEDs. And that's what, when he was talking about making your own backlit panels, if you design a circuit board that has surface mount LEDs on it and basically drill those holes in the back of the panel that allows the light to bounce around inside that clear acrylic. That black base coat stops the light from escaping, so it can only escape through the areas where the white is, and that's how they get those panels to glow. So that's the more that's kind of the more standard way of doing it. The simplest way is just to engrave it. Of course, it's not backlit, but if you actually want to backlight it, then you would put those LEDs on the backside.
Engraving it using what?
Laser.
Laser.
Right.
Use CNC as well.
Well,
I think I understand what you're doing. You want to make your own panels, that's correct?
Yeah, but it could be on knobs as well. I mean,
I understand. I understand your question. So it's made this way. It's a 5 millimeter clear acrylic, then it's a white acrylic clear coat after that, right? So that it's white. Those are compressed together. Then they're painted per what he said there, right? But what your next question is going to be is when I put in the LEDs or I put in the light bulbs, how am I not going to get warm spots? That's what you're asking, right? That's effectively your question. So on the rear, on the rear side of the panel, when you turn it over, you're going to have an aluminium blacking plate, correct? Right? On that backing plate is going to be a thing called FRP4, right? That FRP4 is where you're going to mount your LEDs, and those LEDs are mounted on 1-inch concentric circles starting on the bottom left, working the way up. So everywhere that a concentric circle crosses in the center, that's where your LED goes, and you won't get warm spots.
I was just wondering if you could talk a little about force feedback, and if you have implemented it, and if so, how did that process go?
Sure. So I have active control loading, which is the equivalent of force feedback from the 737. I spoke a little bit about it, but I'm using AC servo motors. And the way it works is when an axis is connected to that motor, so you push against it, and the motor is always trying to center itself. So that's how I center the controls. But then additionally to that, I could make the motor move with the software. So I can control, for example, the autopilot. When the autopilot is on, the servo motor moves and it moves the control, so it'll do the follow. But as far as like force feedback, the feeling on the 737, one of the factors is the airspeed. So as the airspeed increases, so it's not even that complicated, right? It's just the airspeed. As the airspeed increases, then I'm increasing the torque that it takes to move that motor. So it's going to be harder to pull or to push forward. And it's really mostly on at least on the 737, it's mostly on the pitch, not so much on the ailerons, on the roll. And I'm using just Chinese servo motors that you can buy on eBay. And I mentioned the software is open source. And it has a driver box, and I'm using Arduino to control the box. Yeah. Yeah, right. Yeah. So the question is about how I figure out the gearing of where the planetary gear. So yeah, it was a little bit trial and error, and unfortunately, it's very hard to get under. So I have to get under the cockpit, which I have like 18 inches, and these motors are like 10, 15 pounds. To sit there and mount them was very hard. So I did I did a 10-1 ratio planetary gear, and it was too wobbly. Like for the autopilot, it's just too shaky, and I ended up going 50-1, and I tried that, and it was perfect. So yeah, a little bit trial and error. Now that if hopefully you meet somebody who has done it before that went through the process, and then you get a better idea. For the rotors, I use a 3-1. The columns are heavier, so it's going to need a higher ratio. The rotors are not as heavy, so I use a 3-1 or a 5-1, and that worked perfect. Yeah.
There's an alternative, right? So the question becomes really of how much external space do I have for the unit, right? So you can go the electrical route that gentleman's gone, or you can go the hydraulic route. What is your preference? then I'm unable to. Yeah, I can't help you any further unless you had a hydraulic solution, because mine's all hydraulic, whereas Fabian's is electric. You use the actual aircraft, right? So you have the hydraulic pumps powered by the engines, and then it becomes automatic because the hydraulic system is passive. It's just what you do when it breaks, right? Because it's X thousands of pounds of PSI that's going to cut you in half. But that takes care of all the control loading, because you're going to have the artificial fuel units of the aircraft in situ. So you don't have to do all of the math that Fabian's done, because I'm not that bright, right? So it does it for you. Does that help you at all? Oh, jolly good.
But your neighbors must really hate when you rotate those engines there to get those pumps to work.
I'm in Texas. The good Christians love it.
I had a follow-on question about the control loading. I was curious, have you managed to work out how to integrate trim on the pitch loading?
Yeah. So I tried a few different things. Originally, when I did it, when you would trim, I would actually move the column, because you could move the position of the column, right, as I'm trimming. But then I found out that wasn't very accurate, actually. That my understanding is that it actually doesn't move. So when you're actually in flight and you trim the pitch, it is not really doing anything. But for the trim, for the ailerons, for the rudder, they do move on the 737 at least. So if you use the trim button, it'll physically move the wheel to the position you're doing. It'll hold that trim. Same with the rudders. And it's the motor doing the movement, and it holds that. So it's changing the centering position, and it holds it in there, and it's software based.
So you've worked out how to calculate what the neutral position would be.
Yeah, it's
when
off
the
centering
aircraft- when the aircraft is trimmed.
Yeah, it's off centering the neutral position.
Okay.
Yeah.
All right. Thank you.
Yeah.
Other questions?
One thing I didn't touch on because we ran out of time, but power is kind of a big thing when you're building your sim. I started out with one 20 amp circuit in my garage, which I rapidly started blowing all the time. And I had to have an electrician come in and wire some additional 20 amp circuits. So yeah, I've got 3 dedicated 20 amp circuits now that run my entire simulator, because I've got 5 PCs that run, 2 visual PCs, and then instructor station, some others. So it can quickly add, especially with today's graphics cards, 4090 sucks up a lot of power. If you got 2 4090s, because you got 2 visual PCs, so you can see it adds up really quickly. So just be prepared for those requirements as your simulator grows. And if you can find places to cut power, it'd probably be a good idea.
So one tip on that, so the autopilot in my simulator came out of the real aircraft, the light plate, so basically that acrylic plastic, just the light plate draws somewhere between 1.5 and 2 amps. One light plate for one panel. That's not any of the internals or whatnot. So now imagine 15 additional panels on the overhead panel, the instrument panel, all of that. It starts to add up really quickly. So there are a couple of things that you can do. Number one, for backlighting, if you take Fabian's approach and actually do power it with 400 hertz AC, as you should, the power draw drops tremendously. What some people will do is when they find the parts on eBay, they say, hey, I'm going to try to hook up 5 volts DC to it, and it will work. But the current draw is going to shoot through the roof, right? So if you can power it with 400 hertz AC, your current will drop quite a bit. The second option, less desirable, is I have seen people take the bulbs out and exchange them for LEDs, and I've seen that reduce the current draw tremendously as well. So those are a couple options.
Again, I've got to be different, right? So what I have is I have dedicated environments for my toys. My toys are not in my house. I have just shy of 1,000 amps coming into one core unit, which is then separated out for both the units. I found that with the 7.4 in particular, I kept the aircraft wiring, right? So The only thing I needed to do to make those work was, and it's really, really simple. It's about $7,000 for a decent 400 hertz, 28 volts, 400 hertz frequency converter that will go down to 240 and then convert it back to the airframe, right? So that's the $7,000 outlay. That takes care of your AC power. Your DC power on the 7.4 is you've got all your DC power buses, etc. They're Chinese, $12, almost $27 each, and that's your powering done, right? So the money in running the sim, the way that I've done it is in the converting the 240 feed into your 400 hertz.
Well, we could talk about this for hours. I mean, there's so much that's involved in all of these builds, but we're pretty much out of time. Before we close this up, or is there?
Right. So I just wanted to add a bit. So if you take the aircraft cockpit with the aircraft wiring, everything works automatically. All your lighting works. Everything works. Right. So you can't really blow your simulator up if you're using it real because the circuit breakers will work.
All right, any last questions? Yes, sir.
In the real world, we use like companies like Flight Safety, CAE for the simulation. Do you consult with any of these people, or do they make sims on their off time? Have you, I mean, in the community? I don't know. Just curious. Because I mean, I would feel like that would be a good source in some ways. Because I mean, they're obviously multi-million-dollar sims, but maybe they have some spare parts or something. I don't know. Just a thought.
Because they are multi-million-dollar sims,
Right.
They want to keep their multi-millions.
And part of the problem is that they have to be certified, right? We don't care about certification. So, well, okay, certain people do. Yes, because he's always got to be different. but the rest of us normally don't have to worry about certification, so we can get parts at much cheaper prices. But if you're working with
like solving the culmination problem, because it seems like the
Yeah.
visuals aren't great, but that's never been an issue in the level of these sims.
Yeah. Well, yeah, but of course, mine is an older version that nobody's using anymore. So, trying to get help for that is pretty slim. Finding the right people. There's a company in Austin called Doty Optics that kind of specialize in optical, mirrors and all that kind of stuff. So I'm working with them to get that figured out. But yeah, it's all pretty intense physics, and so there aren't that many people that do it.
So what is the hardest thing, the software, or is it just the hardware to do it?
The hardest thing is it's more just the software and the alignment. I mean, the physics is just like anything. Once you get it set up, it's fire and forget. But then it's all maintenance via the software, making things work. So yeah, we'll get there. Keep an eye on my website. All of our stuff is on our websites, right? Do you have a website?
Yeah, that's about 70% of the answer. The issue with single point eye point collimated displays is the age and the integrity of the system, right? So they weren't designed for a digital solution. So the beam splitters and the mirrors are geared for CRTs that have an offset, right? And they're curved. So the kicker comes that when you're kicking them over or converting them over to a digital environment so that you can get all the bells and whistles, right? Is you're not getting that, what's the word? Reflection? There's some really fancy word for it. It's not bending. It's not bending, right? So the LCD environment, you've got to do the physics for a flat to project onto a curve to go back to another curve, right? And that's where the problem lays.
Looks like we're out of time, but thanks everybody for sticking around. And it's been a long day, but thanks so much.
Thank you.